Hello, I'm Ryan, a metallurgist at Paulo. In this Metallurgy Minute, we'll be discussing a few different types of hardness testing. Paulo uses a variety of types of hardness testing to ensure the parts we process meet our customers' specifications. Our most used include Brinell, Rockwell, and Microhardness testing. First, we'll discuss Brinell testing. Brinell hardness testing was the first widely used and standardized hardness test in manufacturing. It is a relatively simple test where a hardened steel or carbide ball is pressed into the material at a given force. The diameter of this indent is then measured and used to calculate the Brinell hardness number of the material. It is especially useful in hardness testing materials that can have localized hard or soft spots, like many cast irons do. One of the downsides of Brinell testing, though, is the large indentation left on the materials, which is often 2 to 4 millimeters in diameter. Arguably, the most widely used hardness testing scale is the Rockwell scale. Rockwell testing can be performed on much smaller and thinner parts than Brinell testing, making it more versatile. Rather than pressing an indenter into the material and measuring the size of the indentation, Rockwell tests the hardness by pressing in an indenter and precisely measuring the depth that it travels. This depth is then used to calculate the Rockwell hardness. By using different indenters and test forces, Rockwell testing can be performed on many different materials. Anything from soft copper alloys and aluminum to case-hardened steels and high-end tool steels can have their hardness accurately tested on the Rockwell scale. The final type of hardness testing we'll discuss is microhardness testing. Some of the microhardness tests Paulo performs are Vickers and Knoop testing. Much like the Brinell test, these tests press an indenter into the material and then measure the size of the resulting indentation. In this case, the indenters are precision ground diamonds. Microhardness testing is often chosen because of the small size of the indentations, typically much smaller than a millimeter. This makes it ideal for measuring case depth on carburized steel, the hardness of thin surface coatings, or the different phases of a microstructure, for example. But at Paulo, we're experts in the hardness testing of metals, so reach out to us today to get the tight control on hardness that you and your parts need.